it's, anybody see it? I put the YouTube link in there, right? There's also other things for direction. So both of these calculators, 83, 84, and 89, all of them can be complex matrices. There's some disinformation out there that says they can't. Now, if you're going to get complex matrices, be prepared for complex matrices, or at least complex equation solutions. You're going to have to do them. And I've made out the exam. There's 2 different exams, but you're going to have to know how to use your calculators. And again, on these things, the way they're scored, they look for the equation and then the right answer. So it's roughly 50%, 50%. If you get the right equations, for loop equations or whatever, that's 5 points. If you solve them right, that's another 5 points out of 10. Follow me, class? So make sure you do that. And sign errors are not tolerated well. That's considered a concept error because you can't tell whether it's a gain or a drop without a sign error. Yeah? There's 4 major problems. Each problem may have multiple things they ask about. For instance, with the transient solutions, right? I may want a voltage on a capacitor, then a voltage on a resistor, and a current through a resistor, if you remember those, right? Same problem set, or same exact circuit, 3 different things I'm asking about. And usually you can get one without the other, not always. Okay? Any questions specifically before I, yeah?
Oh, sorry, I was just gonna ask about the home run.
Yeah, sure.
Oh, okay. Can you do 433?
Yeah. Get your calculators out. Make sure you know how to use these things. Don't wait till the weekend to learn. Just come Sunday night, you'll try.
I didn't look at the video. I know how to do like converting it to ELEC, but I don't know how to do like the actual matrix multiplication.
433?
Yes. Yeah.
Which method? They're asking for no here, right?
Yeah.
You can do it anyway, but for nodal, automatically you put a ground in, right? 0 volts. Right? That's your first thing. Next, I'm going to tell you, for this one, it's real nice. You take one look at this. Look. If that's 0 volts, what's V2? Just by looking. How many see it's 10 volts? There's no equation we solve. This is 10 volts. And you can forget the angle, because that's 10 volts difference, right? It's plus to minus 10 volts. That's 10 volts above ground, and ground is 0 volts, right? Now, that said, this equation, we're only going to need one equation for this one. So we're going to use nodal or Kirchhoff's current law. So here, we've already got this current, right? We've got this current. We'll call this I0, and we'll call this current just I1, all right? So if I use Kirchhoff's current laws, because that's what nodal is about, current going into this node, you all see that's a node right here, right? We've got 3 things connected. Current coming in is 6 at an angle of 45 degrees. That's equal to current going out, I0, plus, and I'm going to call this I1, going this way. It's smart to write that out. I know many of you are tempted to just put in the volt in terms of voltages. Don't do it. Write it out. Now once you have that, the next thing you're going to do is put 6 at an angle of 45 degrees here, equal to I0. Well, what's I0 in terms of the unknown voltages? Class?
V1 over 2.
V1 divided minus 0, right? Because on the other side of that resistor is 0, correct? Divided by 2, so it's just V1 over 2 plus, and what is the current flowing this way now? That would be I1.
V1 minus V2.
V1 minus V2 over
J4.
minus J4, right? Minus J4. Do y'all follow me? Yes, sir. I can't understand. You say V1 minus V2 is what? No, it's divided by J4. Divided by minus J4. Because that's the impedance here in ohms. You all see that, class? That's all. It's only divided by minus J4 because that's the impedance. How many see this right here? What I've done. Now, this is the equation, but what can we do with V2 right here, guys? What is V2? 10. Just put 10 in. Now we're solving for V1, only V1, correct? At this point, it's up to you how to do it. What I would do, to be honest with you, I would go ahead and just multiply. See, this minus J4 doesn't, I don't like it. 1 over minus J, just for the record. 1 over J is equal to minus J. J is really equal to e to the J pi over 2 radians, or e to the J 90 degrees, just so you know that. That's what J means. It's 1 at an angle of 90 degrees. Follow me? These are all representations. So if you want to, and it's up to you, I could say, I'm going to multiply first everything by 4, and so I'm going to have 4 times 6, or 24, at an angle of 45 degrees, is equal to 2V1, because I'm multiplying first by 4, and then it's going to be plus V1 minus 10 over minus J. I'm just showing you one of the possibilities. Does everybody see what I've done there? Multiply everything by 4, right? Y'all see it in the back, guys? All right, now what I'm going to do is this. Well, 1 over J is minus J, therefore 1 over minus J is J. Agreed with everybody? So 1 over minus J, I can write that as, this is going to be 2V1, then it's going to be plus JV1, and then it's going to be minus J times 10 here is equal to 24 at an angle of 45 degrees. You're going to have to get used to doing this on your calculators. Are you with me, everybody? I want to make sure. Got it? Now what I'm going to do is take that minus J10 to the other side. So I'm going to add J10 to both sides. Then I'm going to factor out V1. Everybody follow me? This is just going through the motions. This determines the solution, but now the correct solution of that equation gives you the exact value. So now I get V1 here would be equal to J10 plus 24 at an angle of 45 degrees. All that is going to be over 2 plus J. Try this in your calculators. And I'm going to ask for all the answers in polar form. Yes, sir?
On the test, to avoid like algebra mistakes, once we get our initial equation set up with like one variable or our system of equations, can we just use the solve function?
Sure.
If we don't want to perform any.
I mean, if you know what you're doing, this is the question. I'm always telling people this. I don't know what you punch in your calculators.
Yeah.
But if the answer's wrong, it's wrong.
I'm just saying,
But
if I don't show the word, if I show initial equation with one variable, solve it.
if you can get that in the calculator, spits it out fine. I mean, really. Because that's what you're going to use calculators for. But you've got to enter it correctly. Anyway, this is the answer. All right, but it's not the final form. In polar form is what I asked for. Polar form is going to be magnitude and angle. Follow me, class? So you're going to be expected to do that. So please go ahead and do this on your calculators. Now, I'm going to tell you a couple of ways you can do this. One, if you're going to enter all your numbers as polar numbers, J10 is just going to be 10 at an angle of 90 degrees. That's all J10 is. Follow me? Or 10 at an angle of pi over 2 radians. if you're a radius. You can do it another way. You can say 24 at an angle of 45 degrees is really 24 over the square root of 2 times 1 plus j. All right, you can do that. So you can break that into a real and imaginary part. But I want this in polar form. So give me some of the answers you get. You're going to be surprised how much you don't know about your calculators. You're going to have to be very efficient with these for the test. Because you're going to get, what
Would
get?
you?
14.25 at an angle of 31.2.
14.25 at an angle of, say it again?
31.25.
All right, and that would be volts. By the way, what would the current I naught be? That's what they asked for. Class? If that is V2 or V1, what is the current I naught? It's just going to be that voltage over 2, so the current should be 7.125 at an angle of 31 degrees, 0.25 degrees. Is that the right answer? Whoever asked me? Did you get I naught equal to 7.125 at an angle of 31.25 degrees amps? Who asked me this question?
Oh.
Is that the right solution? Answer?
I'm not sure.
Does anybody have the solutions up? I posted them, didn't I? Y'all got the solutions, right?
Yeah.
Wait, is that the right solution? I'm sure it is, but if what you're telling me is the truth. You have it? Can anybody check on it? Yeah, is it right?
Yep.
It is right? Okay, good deal. What's up? Yeah,
I think he said so.
that's the answer right now.
24.
0.125. It's just that V1 divided by 2, right? Here's the reason why. The voltage V1 is between here and ground, right? The resistance is 2 ohms. Just divide voltage by resistance, we have current. Y'all see that, class? Everybody good? All right, other questions? Good question. Anyone?
I've got another question. So, when you solved for V1 initially, you converted, did you convert all the things that are multiplied by J into the degree form?
Well, I put it right here. I didn't care how you did it. I didn't do it, remember, you did. And everybody, you see, people have their own calculators, their own preference. A gentleman back there said he can enter it all into his calculator and just hit solve. I think he put this one in, but I'm not sure what he did.
I can enter in J, but I can't enter in the degree forms, the radial forms.
All right, I'm gonna let, what kind of calculator?
Well, I've got a TI-83 and a TI-36 Pro. Both of them, neither of them was using.
Anybody got a TI-36 Pro and know how to do this problem?
Yeah, you can do it with 36.
Can you show him?
Yeah.
Wait.
I don't know if you can print in polar form. There's no option for it.
Yeah, you can.
You can. See if you get a
Hey,
second.
guys?
It's
No,
not
no.
complex.
Hey, why don't you do this? Sir?
Oh, I see. Yeah, thank you.
And there's a lot to learn about your calculators, a lot that you don't know. And I know 83, 84, 89s, whatever this other one is, 36 Pro, and all the other HPs. I've got an HP. Nobody seems to use HP anymore, so I don't even bother bringing mine in here. It's still working something. Does anybody have an HP in here?
I have
You
it.
do? A miracle. What? What? I can't hear you.
So this is,
Oh, it's a new one.
I think you,
Oh.
the trap just this one into the.
The old ones are hard to use because the way you solve it, it's not as intuitive as like a TI, the HPs
Well,
are.
HP is a reverse Polish notation. I can say that in Polish. You just think it's reverse. It's just like a stacked number, and that's how you solve it. But I'm used to that, and it's very efficient because that's what a computer does. Any other questions? No. Yes.
So, me and someone else are having a little bit of confusion about your definition of a node.
All right. Listen up. He's asking about what a node is. Here it is in a nutshell. A node is a junction, right? A point where a voltage is constant, but there are more than 2 elements connecting it. For instance, this I don't consider a node, even though you could by definition say that if you have R1, R2, that's not a node. That's just a connecting point. A node is something where you can get current in and flowing out more than one way, and it's the same potential.
So that-
So this would be a node here. If there was another leg here, it would be a node, right? This whole thing can't be a node unless it's called a supernode, and that would be a voltage there between them.
So that bottom portion, that would be one node, not 2 nodes, because
The bottom
that's-
portion is ground, right? You don't ever think, it is a node per se because it's a single voltage, but where our equations aren't written with respect to anything but that being 0 volts. You never put a non-zero voltage there.
But-
Nodes usually have non-zero voltages.
But we're kind of setting that grounds up arbitrarily.
The ground system, remember, voltage is between 2 points, right? So I'm going to pick one point and make it 0, and every voltage is measured with respect to that. The reason I do that is in the equations, I don't have to keep having V1 minus some 5 volts, because I put 5 volts at the ground, at the point where I'm calling ground. You always make ground 0, it reduces the mathematics, the level of complexity of the math. That's the reason to do it. Right? Technically it is a node, but it's already solved for, you don't solve for that voltage, you put 0.
But that node that you're referring to, that
What
was set to
node?
ground,
What node?
the one that we set to ground.
Yeah, here's what it comes down to. Normally, in any circuit that you can imagine, you're going to have some point in that circuit where it has the most amount of connections, right? That's where you put the 0 ground, unless there's a tremendously good reason not to put it there, right? So if you take a look at this, you all see how all these things are at the same point. Just put 0 volts. Because if you want to solve for that, you make a ground here, it's stupid. You're going to have crazy equations. Just leave that as 0. All right? And I'll just tell you this for the test. The bottom, I call it a bottom rail, that's the way I term it. The bottom here is ground. Got it? No mystery. Now, other questions. I hope I'm clear about that, because I'm not trying to, not give you a good answer, but the reason is it makes the problem easy. That's the reason I always put that at 0. Yeah?
What type of equations would I calculate and have to solve?
Matrix equations with complex numbers. If you look at that YouTube video, the kid does it for literally a problem that we're going to get later in Transformers. He's doing the thing with complex numbers. All right, how many seen that, what I put up there? 1, 2, just a spatter, not many people. It's a good video, all right? And there's a lot of them that show you, they got problems that we're doing solved on the internet. They show you how to put it in your calculator. Cracks me up that these are probably my kids that did that. Go ahead.
You work 4.34.
Yeah. Now get your calculators out. Make sure you know how to do these.
Yeah. Yeah, I just want the 2 angle 45 on that.
Yeah, exactly.
J4 and 4J? No. Everything, it changes the whole circuit. It flips it upside down.
All right, this is the problem set up, and even in the problem, he shows you the symbol for a ground. It's like that, and that's 0 volts. So he's telling you that's where the ground is, which is nice of him. Now, when you have that, he's after this current I0, right? But really, he asks for you to do it nodal, right? Use nodal analysis. So there's 2 nodes. Here's the first, and we just put an unknown voltage V1 there. Here's the second. And we can put V2 here. So now I've got my unknown voltages. Now you're going to be expected to put those in. I'm not going to, unless if I do supply them, all right, then you'll use what I indicated in node values for V1 and V2 if I ask to solve those. But generally speaking, you would put those in for say nodal analysis. Now that after that, then you find all the currents into equal all the currents out of the node. There's the first node. I'm going to have a current here, call it I1. and I'm gonna have a current here, I2. Second node, I've got another current, that's already labeled as I0. So for my first node right there, when I write the equations, you'll notice that nothing's flowing in. Can y'all see that? And my convention is always going from top to bottom, from left to right, as far as the direction of currents. That's a standard I use. If you stick with that, you tend to be less likely to make mistakes. So with that in mind, I have I1, right, plus 2 at an angle of 45 degrees, plus I2 equal to 0. Y'all give me that? All right, class? I want you to do this one in your calculators. Make sure you can. Get them out and get ready to work on it. Because don't just assume I'll pick it up this weekend. Now is the time to figure out what you don't know. You won't figure it out Sunday night. Almost guaranteed you're going to be flipping around YouTube and you're probably going to be more confused and panicky than you've ever been. So try to do it now. I'm doing my best to level with you. Over here, I'm going to take this to the other side, 2 at an angle of 45, okay? So that becomes minus 2 at an angle of 45 degrees, amps. Now, I1 here, what is I1 going to be by my designations? Say, V1 over what? J2. Over J2, thank you. All right, plus I2, what is I2 going to be?
V1 minus V2. Negative J4.
Over?
Negative J4.
Minus J4. Now, somebody said, well, can't I just put these in the, if you can put this entire equation, or I should say the coefficients of this into your calculator, fine, you can do it that way, and you can just solve for V1 and V2. You'd have to have a second equation. But what I'm going to do is just suggest a simplification. This is me. I do this stuff a lot. You're going to see all sorts of stuff on the internet about this. What I'm going to do first is multiply everything by 4, because I don't want any fractions. That's me. I don't like fractions if I don't have. So if I multiply by 4, then I get a 2 up here. I get rid of that, right? And I get an 8 here. Now, I'm not going to rush through this one. I want to make sure you see it. Y'all understand what I've done? I don't like fractions. That's the reason for it. You don't have to do it this way, but you'll find, I think, that it's probably the best way for most of you to make the minimal number of mistakes. Now, at this point, I could multiply through by a j, or I could simply take, remind myself that 1 over j is minus j, right? So I could put a minus j here, right? 1 over minus j is j, so I can put a simple j there, right? And that would be the correct equation. Does everybody follow me? I've just taken the 1 over j's and made a minus j's, or the 1 over minus j and made a j. Does everybody see what I'm doing here? Yes, sir.
Why did we do V1 minus V2 instead of V2?
What, say again?
Why do we do V1 minus V2 instead of V2 minus V1 for?
It's V1 minus V2. Because I want the current flowing this way, right? It's V1 minus V2.
I thought it was the difference in pressure of the second one.
What are you trying to do? You're trying to find the current that way, right? It's always the voltage on the side, the current's entering, minus the voltage on the side, current's leaving, divided by the impedance. How many know that? Class, make sure you do. That's the way we assign positive current. Voltage on the positive terminal minus voltage on the negative terminal divided by the impedance. That's the way you do it. Now, we've got this, right? Everybody? Now write the equation in terms of the coefficients of V1. And by the way, there's so many different ways to do this. Right here, I'm going to just do it. I'm going to put V1 here. The coefficients are minus 2, and then it's going to be plus j, right? And then plus V2, and the coefficients for V2 here are going to be minus j, is equal to minus 8 at an angle of 45 degrees. That's the first equation. And then put a box around that final form of your equation. Now if I multiply this by any scalar number, by 10, 100, or quarter, it's still true. Follow me?
I think the coefficient for V1 is supposed to be minus 2j plus j.
Minus 2j plus j, I'm sorry about that, you're right. It's minus 2j plus j, and that would be equal to just minus j. I'm sorry about that, you're absolutely right. That would be just minus j. Thank you very much. Okay? Here's what I did wrong. You see that it's minus 2j right here? minus 2j, and j is just minus j. Got me on that? All right, that's all I did. Y'all see it back there or not? You guys? All right, I gotta make sure. Can y'all see this stuff far back? All right, so now I have this equation. That's the first one. Second one, we do the same thing. And remember, the only thing different that we're doing is now we have, instead of just real valued resistances, we have the possibility of complex valued resistances. Think of it that way. Over here, how much current is flowing into this known class? I2, right, plus 4. Agreed? Because 4 is flowing in, right? How much is flowing out? Just I naught. If you get used to doing it this way, you won't make mistakes. What flows in, flows out. Now put in the voltages. Well, what flows in? I2 is what, class? Can you see it?
V1 minus V2.
V1 minus V2 over
J4.
minus J4, right? Over minus J4, correct? That plus 4 is equal to I naught. What is I naught, class? V2 over 2. Over 2. All right, there's the second equation. Y'all see how I got it? Again, just the voltage differences across the actual components divided by the impedance of the components to get the current, right? Everybody? Now, how you solve it's up to you. Again, you can almost guess what I'm going to do is first thing multiply by 4. I don't like fractions. I multiply by 4, and I get 16 here, and then I get 2 here. Right? After that, I'm going to take the 16 to the other side. So now I'm going to have minus 16. Right? Then I take 2v2 to this side. So now I have, better yet, before I do that, I'm going to get rid of this together right here. 1 over minus j is j. So that's j and that's j. Now, having said that, the next thing I'm going to do is take that 16 to the other side. And then I'll take the 2v2 to this side. So I have jv1 minus jv2 minus 2v2 is equal to 16.
16.
I couldn't hear. Minus 16, thank you. There's the trick I do. I circle minus signs because my eyes are bad. I don't know if you've ever missed a minus sign, but when you're doing work for money, lots of money, you don't make those mistakes. You can't help it. So that's one of the tricks I do. Everybody got that? All right, now after that, you get in terms of the matrix form. It's V1 times J here, then it's plus V2, and the coefficient of V2 is going to be equal to minus 2 minus J is equal to minus 16. That's your second equation, right, class? Now, you have to do this on your calculators. This is a complex matrix you're going to have to solve. So here, I take the first equation, and I do this. I take the coefficients there. I've got minus J, minus J, minus J, minus J, V1, V2, equal to, then in the block form on this side, first coefficient up there is the coefficient on the other side, minus 8 at 45 degrees. Here I have minus 16. Second set of coefficients, I have J, and then I have the quantity minus 2 minus J. Now I'm going to tell you, there's a lot more things you could do with tricks on this. I'm showing you the basics, how I would do it if I was you, where you're sitting. Make it simple, don't make it hard. Make it as simple as possible. Now this matrix is your A matrix. That's A. This is X equals B. That's B. When you have solvers in your calculators, they'll have something that allows this form to be entered. I don't know what the forms you've got, but basically you're going to be entering these as A11, A12, A21, and A22. And then this is simply B1 or B, just B1, and it's, I guess B2 is simply, it's going to be a column vector. Y'all see this, class? And then you gotta solve it. So then you gotta give me V1 and V2 in polar form. I wanna see what you guys get. V1 and V2. Now this is polar, so it's magnitude negative. You're gonna have to do this and do it efficiently. So first test, there's a lot of people that flunk, and then unfortunately they never recover and they end up, I don't know what percentage flunked the last time in this class, but it's easy to get 20% failure in this class if you're not careful, if you're not up to speed. It's very easy to flunk this course if you're careless, I'll be honest with you. If you work hard, you get it's easy to get a high A in this course too, but the thing is, it's really a teetering thing. If you aren't keeping up with the homework daily, you try cramming. First test, maybe you get a C or D. By the time you get to the final, it's comprehensive, you'll fail sideways. You just stare yourself in the mirror. Why did this happen? Keep up with this stuff. Don't let it pile up. What do you get for V1? Polar. Anyone? Still working on it? Get your calculators out, learn how to use them, man. If you don't know. All right, I'm gonna ask this. Who has an 83 that knows what they're doing? Hands up. Anybody? Nobody's gonna admit it. 84 knows what, you do?
Yeah, I've been working on it. It takes a while to do this with the 83. So.
All right, just stay there. Does anybody else have an 83? Anybody else beside him have an 83? One. Anybody else besides you? Only one person? Wow. Do you, oh, you two, both of you know how to use your calculators? You do? If you don't, see this guy. That's what I'm trying to do, point out somebody you can see. How about an 84? Does anybody have an 84 and knows what they're doing? One guy? Were you up in your hand there or not? You have, how many have 84s? Let's start there. Looks like that's a use guy. How many have an 84 and know what they're doing? Anybody willing to volunteer?
If you know what you're doing, please go up.
You know what you're doing? Oh, you don't know. Well, that video will show you how to do it. Okay, hold on. How about 89s? Anybody have 89s? Who has an 89 knows how to use them? You. Fantastic. If you have an 89, are you okay with this?
Yeah.
If you have an 89, don't know what you're doing, go see him when we're doing problems. You can literally get up in the class. I'm trying to do my best to help everybody here with the time we have. How about, what is it, 36? Who has the 36? Is that the other one? You? Anybody else? You and you? Anybody else? You have one. You know what you're doing, right?
Not with the matrices.
Not yet?
It won't take a measure of the matrix.
Yeah, it won't do the matrix.
36 does everything else great.
I bet you it does.
But
I bet you if, now I'm gonna have to find that one for you guys. Send me an email to find that one, or look for it yourself. They do it. 36 does that. All right, guys, is there any other calculator I didn't hit on? What is that?
It's an Inspire
Inspire? What number?
CX.
Does anybody have an Inspire CX? You do. Oh man, you know how to use it? All right, if you don't know what you're doing, see this guy right here. You got an Inspire. Do you hear me, guys? I'm trying my best to help you. This is the time you want help from other people that know what they're doing. Right, now, that said, I think the best thing I can do with my time is more problems. Has everybody got another problem they want to see? And you get up in class, if you want to see one of these characters that knows what they're doing, go ahead. Just keep doing roll. Yes, Smith.
Currently
We will. 427 it is. And by the way, you know you can do mesh analysis with this theorem, this stuff. You can do Fabbian's theorem, anything. Did you have another question here?
I just want to know what the answer was to make sure I got
Oh, yeah. What is V1 and V2? I'm sorry. They should be in the solution thing. But what did you get? Anybody? You had your hand up back there. What did you get?
you have to answer that.
For V1.
But how do you type?
I don't know how to type the
2.029 at an angle
I know
of
this. I know that you can go into code and change
minus 1.5 degrees. What about V2? 7.9? Go ahead. Minus 30?
Yes, sir. Yeah, I don't know if it does negative.
All right, class, anybody else get different answers? What'd you get? You got the same? I'm trusting this answer. Usually when you get 2 or 3 people, they got the same answers, it's usually right. All right, so whoever asked that, thank you for asking. I'm sorry, trying to move too fast. How do I get I naught, guys? Just look over here. I'm looking for I naught. What do I do? Take V2 by 2, correct? Everybody see that?
Yes.
All right, now move on to 27, was it, miss?
Yes.
Before I do, any other questions about this? Boy. Is this 1 ohm or 2 ohms right here? They're calling this I naught here. This problem, for this problem, it doesn't say how to do it. It just says do it. I do that too sometimes. I said anything you feel comfortable with, any method at all you can use. Now let me just discuss 2 things you can do. All right, I want you to notice this. You see how we have only one voltage source? Does everybody see that? Whenever you have one source, usually the problems can be done very efficiently by just combining impedances to get a net impedance across it, finding the current through that, and using current division or voltage division to find what you want. Do you hear me? When you have only one voltage, it's very easy. Now let me discuss this. Can you see that the 2 and minus J2 are in series? All right. One single impedance here would be 2 minus J2. That is in parallel with J2. Do you all see that? How many do right here? Therefore, you could take the parallel combination and get one single value, right? Listen, now come down here. You see that these 2 are in series. Everybody see that? Therefore, you could say the 1 minus J1 is in parallel with 2. You could get a single value for that. Understand? Can you see that this and this are in series, right? If they're in series, you can add them together. Then that net impedance, you can divide into 12 and get the current here. I'm talking my way through it. I'll do it a couple ways. Y'all with me here? Once you have that current, that's flowing through both of these, right? And it's coming down here together. And then it's what? It's also dividing between this one and this, right? Now, once we had I naught flowing, the I flowing here, to get I naught, we'd simply take that I and multiply it by the opposite impedance over the sum of this plus this, and we could do it with current division. How many understand what I'm talking about there? That's using current division by getting the total current very easily by just combining things. That's one way to do this problem. Do you understand that? And you would get the right answer. Did you do it that way, by the way?
I did not.
All right. Another way you could do it, you could assign a voltage V1 here and a voltage V2 here. Now V2 minus V1 would be 12. You follow me? V1 minus, and then you could write the equations, and we could do that. And we could go ahead and say the net current coming down is equal to the net current going, basically current going in is equal to current going out. But here you would have one big supernode because you got a voltage between 2 points. That's where you'd use a supernode. Are you with me? You could do it that way. Another thing you could do, now listen, I'm giving you your options. Since the only thing I want is this current, now listen to me. Couldn't I just extract that component, find the open circuit voltage, this is Thevenin, and then turn off the source and find R Thevenin, and then reduce this circuit to simply 2 components, a voltage source and an impedance. Do you all see that? And then you put that thing back, you can get it. That's the third way. Superposition doesn't buy you anything, there's only one source. So you're back to square one, right? It doesn't do anything for you. And you could write mesh equations. You could say the loop occurred here, loop occurred here, loop occurred here. I would not do that because that's going to be a 3x3 matrix for this one. And I don't advise that. Follow me? So I'm showing you what your options are. Now probably the one that makes the most sense to you is just getting a parallel impedance. I mean 2 plus minus J2 in parallel with J2. Get a single impedance there and get a single impedance there. Does that make sense to everybody? Adding those two impedances to get a single impedance, and then taking that single impedance and dividing it into 12 to get the net current flow here, and then using current division. Do you follow me in this class? All right, we'll do it that way. Who asked? You asked this question. I'm going to do it that way. Is that all right? All right. If I'm going to do it that way, first I need a net impedance for this. So I have 2 minus J2 in parallel. That's the symbol for parallel with J2. Now, that's equal to, you can take that impedance, 2 minus J2. Your calculators will do this very quick, by the way. If you want two parallel values, you can go ahead and you could just say, well, it's technically Z parallel would be equal to 1 over Z1 plus 1 over Z2. Watch this. Well, now it's equal to 1 over Z1 is just 2 minus J2 plus 1 over Z2 is 1 over J2. Your calculators can do this in a heartbeat, right? And you can get a single value. The other way to do it is to take the first times the second over the first plus the second. You see how this is going to work? So it's J2 minus J2 goes away is just 2, right? You follow me on this, guys? You guys getting this in? I'm showing you how to do this. I'm showing you how to get parallel combination impedances. Here's Z1, here's Z2. I multiply them and divide by the sum. Now what does this come out to? Well, that 2 cancels that 2. And what am I left with? I'm left with J2, and then J times J is going to be minus 1, but there's a minus sign. So it's plus 2 is equal to that parallel combination. You all see that? Yeah. All right. That's the first one. What about this one right here? The parallel combination would be Z1 times Z2 over Z1 plus Z2. How many understand that? That's parallel combinations for resistors and impedances, right? In other words, just to be clear, if you have some Z1 here, and impedance, complex, it could be real, and some Z2, right? If I wanted to know what the effective impedance here is, Zn would just be equal to either 1 over Z1 plus 1 over Z2, or just take this equation and multiply top and bottom by Z1, Z2. Then you get Z1, Z2 over Z1 plus Z2. You all see that, class? This is the one I'm using here. So for this one right here, the second impedance, I can say that this Z parallel here would be equal to 2 O times 1 minus J2 over, then it's 2 plus this, so really 3 minus J1. This one, you can give me, if you take a look, I can use what's called, I can use a complex I can take this thing and conjugate it and multiply top and bottom by that to get a single value. But this is really going to be 2 times 1 minus J2 here, and that's going to be 3 plus J1. Downstairs it's 3 minus J1 times 3 plus J1. Here, I'm going to get downstairs, I got 3 times 3 is going to be 9 plus 1 is 10, and on top, then I'm going to have 2 times 3 plus J1 minus J6, and then plus 2 1/5 times 5 plus J5. So this should be 1 plus J1. Do you get that, class? When you do it? What did you get?
I got 0.8.
That's couldn't hear what.
0.8.
Is this coming out to 1 plus J1 on these two? Can you do it?
I got 4/5 minus 2/5 now.
And what did I do wrong? Did I miss it?
You have J2 in there, J1 on top. In the beginning,
Right here?
there should be J1 on top, I believe.
Oh, you're right, that's my bad. That's right. All right. So it's 4/5 plus J 4/5, is that right?
4/5 minus 2/5, or J.
4/5, say it again,
4/5 minus 2/5.
minus J 2/5. Okay. Is that it? All right, so that's that impedance, the parallel combination. Now, the net impedance is gonna be what? It's gonna be this plus this, right? Class, y'all see that? So the Z total, the total impedance here would be equal to 2 and 4/5. Well, 2 is really 10/5 and 4/5 is 14/5. All right, plus, and then it's going to be, that's going to be 10/5 minus 2/5 is 8/5. So is that what you're going to do? Guys, I'm adding, just adding, right? Follow me? When you add them up, you get that, that's Z total. That means this current flowing out of here, and this one I want in polar, all right? This current right here, I'm gonna call that I source. I source here would be equal to 12 divided by, and then it's gonna be that Z total, whatever that is. Now give that to me in terms of a polar number, please. A magnitude and an angle. I want it in terms of polar because I want you to get used to using the polar function. How do you convert a number to polar? You're going to be doing that on the test, so I want you to do it here. All right, say that again, sir. 3.81. 2.8, sorry. 2.81, go ahead. No, I don't want I want I. 3.023 at an angle of?
-1.85.
All right, and that's amps. Is that what you guys got? Did you get that? Anybody get this? Nobody got that. I'm suspicious. If this is the total impedance right here and you divide it into 12, that number should be something we all get rather easily, right? What do you, I mean, if that's not it, let's get the right answer. Can somebody do that for me? Go ahead.
I got 3.72 at an angle of negative
3.72 at an angle of what?
Negative 29.
That's what I got.
0.7 degrees, roughly. How many got that? All right, you're doing it right. Make sure you can do these things efficiently. Can you hear me now? Make sure you can do them efficiently. If you don't know how, yes, miss. Oh, hold on. Say again. We added the Z's of this parallel combination to this parallel. We just add them up. They're in series. Everybody see they're in series, class? All right. Now, once we have that, that's the total current flowing here. Look, it flows all the way around here, right? Now look, it flows this way, right? And then it divides, doesn't it? So this current I naught,
Can you write it down?
let me put it right here for you.
I just wrote down the last part. I don't know.
That current I naught
So you just calculate that.
would be equal to the source current, that's the total current flowing in the circuit, times the opposite impedance, 2 minus J, or I mean 1 minus J1, pardon me. 1 minus J1 over the sum of that plus 2, or 3 minus J1. Now here, in polar form, give that to me. IS is up there. Y'all see what I'm doing here? Just give it to me. Use your calculators now, man. This is where you start fumbling around and don't see something, somebody can help you. They're right here to help you. Anybody? You guys got it back there now? What'd you get? Give it to me. Say it again.
1.66.
Minus 56. Anybody else get that? That's amps, by the way. Anybody? You got it? All right, there's one. You got it?
Check, go to the mode.
In the back there? You got it? All right.
See what you
Again, make sure you know how to use your calculators. All right, another one? We got done.
Wait, so
I think you can't. Like,
Guys, let them talk. Go ahead.
you're going from I naught to IS. You're using, I guess,
Current division.
current division, and you're summing. Could you just like quickly go over how you're summing?
Current division in a nutshell is what? It says if you have two, just listen to people if you don't know this, if you have Z1 here and Z2 here, and I have a current I source going in. If I want the current going through here, I1, I would say I1 is the total current entering the parallel combination. Then it's times the opposite piece over the sum of Z2 plus Z1. This is just like it is for resistors, all right? So resistors and complex impedances are the same. You can use voltage division and current division the same way.
do 8
Got it?
5 times IS.
All right. You want me to do another one or not? You got any other questions?
So I think you just can't put them.
All right. Here's a piece of advice. Get your sleep on Sunday night. Sleep does more good for your ability to recall and work problems than spending extra hours cramming. It usually will kill you, especially if you're drinking a lot of coffee and stuff or on stimulants. Then it just goes kaplowy.